entrance exam. So I told you stability of the complexes depends upon the nature of the metal and nature of the ligand. So you have already written that what on what are the factors the stability of the complex depends upon the metals. We have found the metal stability of the complex depends upon the charge on the metal, that is the metal with higher oxidation number. The complexes with higher oxidation number of metals are more stable than lower. Okay, and also it depends upon the size of the metal ion. So I've given you an example of the metal complexes from the 3D series. So we find as the sizes of the metal ion decreases, the stability of the complex also increases. And I have given you a series which is called Irving-Williams series. Okay. Then it also depends upon the electronegativity of the metal ion. We find if the metals are more electropositive, in this case, you find, sorry, if the metals are less electropositive, in that case you find they form stable complexes with the elements of the higher electronegative complex ligands, like with the atom of nitrogen, oxygen, and fluorine. If the electropositivity of the metal is higher, in this case they can form stable complexes with those elements with lower electronegativity, like phosphorus, arsenic, sulfur, chlorine. Then after that, I told you about the nature of the ligands. So if the ligands are polydentate, that is the ligands which can form cyclic entity by the incorporation of metals, we call them as chelate, and those ligands are called chelate ligands. So chelation makes a complex stronger. And I told you, suppose you have taken a metal complexes with ethylene diamine and the same metal complexes with ammonia, then we find the ethylene diamine complexes are more stable than that of ammonia because they form a cyclic ring. So if they form a ring, 5-member or 6-member ring, they are found to attain very high stability. Then I have talked about macrocyclic effect. If the ligands are very large in size, and if they do not suffer from any type of steric hindrance, and when they form complexes with the metal, those type of complexes are extremely stable. And I have shown you an example also by drawing a framework which is called a tetradentate ligand, which is called porphyrin. We find the porphyrin ring makes very stable complexes to form hemoglobin, and similar ring also forms chlorophyll. Okay. Now, then it also depends upon basicity of the ligand. What is basicity? That is that which you can donate electron very fast. The ligands which are more basic for stable complexes. complexes. Example, ammonia, cyanide are strong bases and form stable complexes. You don't have to worry for your exam. This is not for your exam, this is only for your entrance exam. Okay. Then this is the third one. First is that we have discussed already. That is called the chelation. Second was macrocyclic effect. Third is this. Both size and charge on the ligand. Ligands the anionic ligands which are small in sizes and have higher charge density. Charge density means charge by radius. Form stable complexes. Example, see, fluoride is smallest size. Okay, forms more stable complexes than chloride. See, both of the charge is 1. The size of the chloride is much bigger. So the fluoride complexes are more stable than chloride complexes.
Sir, done.
Okay. Now we'll go for application.
So, wait, sir.
Please remember, in CBSE, your question also comes from application. First, you to understanding the theory and application is there. Okay, so application of coordinated compounds plays a very important role in chemistry. Okay, in Analytical chemistry means what? Whenever you do analysis, test, okay, that is you can say in practical. So in analytical chemistry, coordination compound plays a very important role. Many of the metal ions are the conformative test of many metal ions are being done with the formation of coordination compounds. The presence and conformation of many ions are done by the formation of coordination compounds. Okay, like test for chloride. See, in chloride, what do you do? We take metal chloride and to that we add silver nitrate. You get here silver chloride. Okay? You get here now metal nitrate and silver chloride. This is a white. Okay, I'll write down whatever is there in your book. Cardi white precipitate. See, both bromide and iodide also forms white precipitate. Then how do you know it is chloride? So, to that we add ammonia. So it forms the white precipitate dissolves, confirms the presence of chloride. Okay. So now, same test. The same test also confirms the presence of silver ion. What do you do? To silver ion, we add HCl, we get silver chloride. There is a white precipitate, then we add ammonia, it goes into solution. Okay? Right.
পুরোটাই লাগবে ওদের।
পানীয় বিয়া করিও টিপিক্যাল বাঙালি আমি এটাই আমি দেখবা এর দিস ইজ আই
দিয়ে দাও ওদের বাসায়।
না তো তখন হচ্ছে না তারপর মানুষ প্রমাণ এবং সব ধরনের সঙ্গে যুক্ত আছে তার বাড়িতে কোনো রকম ইন্টারেস্ট হবে
Done, sir.
Okay. See. Similarly, copper ion is also detected by complex formation. Also detected by complex formation. With K4, Fe, CN6. Okay, now this important one is for your practical exam fiber. The presence of nickel ion is detected both qualitatively and quantitatively. I don't know whether you will do in practical or not. Qualitatively means we just get information that nickel is there. Quantitatively means you can find out exact amount of nickel given in your circuit by complex formation with dimethyl glyoxide. This one I'm going to write. Now you know what is called oxime. Oxime to you know. This is called oxime. Oh, sorry. Okay. This is known as NIDMG2 short form. This is beautiful pink color. I don't know whether it's salt analysis you have done in school or not. This is for your Viva.
Second bracket, it's DNG.
Yeah, DMG, short form, dimethyl glycoside. Na? So this is the short form of this one. Like we write EN for ethane 1,2-diamine.
So for the carbon in the second ring, it has only 3 bonds.
Oh yes, good. Many things I forget these days. Yeah, I remember, but so it will be like this.
So the Cu2 plus is also detected by complex formation with
Potassium
Ku,
ferrocyanate.
sir.
Potassium ferrocyanate. This is quite potassium ferrocyanate.
Plus Ka4, K,
Therefore, efficient 6.
or
What about the lower one?
that is Ku.
This is the reagent. This reagent, see, complex formation with. It forms a chocolate brown precipitate. Okay, here you can write. Chocolate brown precipitate. Once in your school, the theory classes are also going on. One son.
No, sir. We're done. We're doing revision now.
So your entire course is completed.
Yes, sir.
It was going so slow. How come it's so fun, finished so fast? Any advanced what? Revision or what? Or no class? Theory class?
So we have theory and practical both.
What?
One day we have to go for theory and for one day we have to go for practicals.
The theory, what is being done now?
We didn't have chemistry theory till now.
Cholai long lip chemistry. Second, determination of hardness of water. You know that why? What is the meaning of hardness in water? What is the meaning? Hmm?
Doesn't
Bolo.
form lather easily.
Huh?
It doesn't form lather easily with soap.
Balai, why it is like this? What is lazy or what?
It has calcium, like presence of calcium
Calcium or
compounds.
Oh, I thought you will tell the water is very lazy. Okay. So
What?
I thought you will tell that
Hello.
water is very lazy, because of that it does not form. Okay. The hardness of water means what? Calcium and magnesium ion is detected by EDTA or minus. I think you know the full meaning of EDTA. Huh? Hello. Moment I ask any question, why there is a silence like graveyard prevails? Ethylene, diamine, tetra एसिटेट. हाँ, हम क्या बोलेंगे? अरे हमको कुछ बोलने का नहीं है. See, this is the one, EDTA. What type of ligand it is? আর সেই ল্যাপটপে ওই সিনেমাটির মতো না দেখলেই হয়. Hello, what is the answer? What type of ligand it is? Why do you keep quiet? What? What type of ligand?
Strong
Huh? I'm hearing only music. So many of you are there. Anyone can tell? Strong ligand. Who is the person who told me strong ligand? Tell me the name.
Drishti.
Drishti, na?
Drishti.
Drishti. Hey. Strong ligand. Rotu. This is hexadentate ligand. See, 1, 2, 3, 4, 5, 6. Okay. Written na?
We're done.
Used in complexometric titration. To estimate various metal ions like calcium, magnesium, lead, etc. See, silver is precipitated. Same is being done with gold. তোমার সাথে জ্বলে গেল।
Excuse me, sir.
Yes.
Sir, what's that after AG?
What?
What's that after 2AG?
This is an arrow, which means it precipitates.
Thank you, sir.
Don't write arrow. না না They are used for electroplating. Today I'm going to do metal carbonyls. One metal carbonyl we have already done with nickel. Okay, and there we have found the oxidation state of metal is 0. Metal carbonyls. Compounds formed between metal and carbon monoxide are called metal carbonyls. These compounds possess both sigma and pi watts. The oxidation state of metals in these compounds is 0. Nickel tetracarbonyl, iron pentacarbonyl. This is trigonal bipyramidal. Chromium hexacarbonyl. This. Octahedral. These are not given in your book. I don't know whether it's given or not. See, these are the bridge. So these are monomeric. You can write down here. So this is this is a very important catalyst. Cobalt octacarbon.
Finished, sir.
Metal caramels are frequently used as catalysts. Bonding in metal caramels. It can be explained by molecular orbital theory. There are two types of bonds are there. Two types of bonds exist between central metal atom. Mind, it is not iron. And ligand. What are those? Sigma bond and pi. See the note which I have given you. There you have mentioned dative bond. What does it mean, dative bond? Because in coordination compounds, bonds are formed through a coordinate bond, where the ligands supply both the electrons to the metal. So this type of bonds are called dative bond. DATIV means covalent bonding through donation of electrons. Okay, but I have made a very serious mistake. All of you have got the note, huh? There, when I'll go to pi bond, I'll tell you what. While writing, I made a mistake. Okay, then I'll write down here sigma bond. Okay, so first I'll explain. See, this is the metal d orbitals. All right. So this is the plus and minus is nothing to do with the electron here. This is the symmetry. See here, carbon monoxide, you know, Lewis structure also you try to remember. You find this is a pair of electrons here. All right, huh? Carbon monoxide. I'll show you carbon monoxide. Okay. Everything you forgot, nah. There is a problem. Carbon has 6 electrons, oxygen has, or carbon has 4 electrons in valence shell, oxygen has 6 electrons. See here. These are the 2 electrons given by carbon. So out of the 4, 2 is here, 2 for bond here. All right. And here you have, this is the one. Now, oxygen has 6 electrons out of 6, you have utilized 2. See here, 2. Then the third bond between them is is being given by oxygen. So this is what type of bond? This is the coordinate bond. These are covalent bond. This is coordinate bond. See now. Look. How many are there? 2 plus 2 plus 2, 6 plus 2, 8. And here 6 plus 2 is 8. This is the one. So here, in this case, this is sigma bond, this is pi bond, this is coordinate bond. Please remember. So this is a dative bond. See here. So in this case, what happens? So this is nothing but this is a sigma bond. Janina Jiga. So this is a dative sigma bond forms between formed between metal and carbon monoxide ligand. Now metal accepts an electron from the carbon monoxide. That is, now you have because this metal I have taken is neutral. Moment it takes an electron, then metal become rich in electron. And metal can never show you a negative charge. But when it is given, in that case, I should write a negative charge. So why you find oxidation state of metal in carbon monoxide, metal carbon is 0, why not minus? That I'm going to show you by another one.
That's right.
Very good. Now, before I go for the pi bond, let me discuss the formation of pi bond. Formation of pi bond. You know from molecular orbital theory what you have learned? That whenever two atoms approach each other, there is a possibility of bond formation, or there may not be any possibility of bond formation. So in that case, you are going to get two sets of bonding orbitals. So two sets of orbitals. One you call it bonding orbital whose energy is lower, another one is anti-bonding orbital whose energy is higher. Okay, so I'll show you. You know, pi bond is always being formed by what? Pi bond is always being formed by the lateral overlap of the orbit, p orbitals. See here. So in that case, so this is the p orbital of carbon, and this is the p orbital. This is very easy, so you need not get squared. See here, we know they have to maintain a symmetry. If symmetry is maintained, in that case, it results what you'll find. It results in overlap. Okay. I'll write now. Sorry, I'll write here carbon, and here I'll write oxygen, carbon, and oxygen. All right. See here, this is plus, and this is minus. So how do you depict it? We depict it like this. Okay, this is the one. So this one is nothing but, we call it nodal link. Okay, this is plus and this is minus. This is what we have to write down. Pi bond. The other, it may, in that case, their symmetry is not maintained. When the symmetry is not maintained, they will not overlap. There will be repulsion. See here. Now, what we are going to get? In that case, it is fine. See, this is pi anti bonding. How many nodal plane it has? It has 2 nodal plane. This is also important for your entrance exam. This is it has 2, 1 here and 1 here. Please remember. Pi bonding has 1 nodal plane. Pi anti-bonding has 2 nodal planes. After carbon monoxide has donated electron to the metal to form sigma bond through a coordinate bonding, in that case, there is the density of electron on the metal increases. Okay. Now we'll go for pi bond. See now, this is the metal d orbitals. All right. So we know d orbital is what is like this. This. And this is the carbon monoxide. This is the anti-bonding orbital of carbon monoxide. Just now I have drawn. What do you? Now through sigma bond, initially when the sigma bond formation takes place, there is excess of the electron is being deposited on metal. So this metal again supplies electron to those anti-bonding pi orbital of the carbon monoxide. So it is metal d orbitals, and this is anti-bonding pi orbital or pi star orbital of carbon monoxide. Now see what happens. So they overlap because their sign is similar. So it will form what? See now. So you can say it is a back bonding takes place. Back bonding is through the metal d orbital along with the anti-bonding pi orbital of carbon monoxide. By that way, the density of electron on metal atom decreases because again initially it has taken from carbon monoxide, again it just paid it back. It's just like that we have taken loan from bank and after that again we paid back. So initially bank has given us the electron of the money. Now we have money, but that money is not mine. So what you do? Again you pay back that money. So by that way, what happens? By that way, in case of necessity, I get stability, and Ben also getting the interest from us, they also attain financial stability. So it is this type of bonding is called synergic bonding. That is, sigma bond stabilizes pi bond, and pi bond stabilizes this sigma bond. So these are called synergic bonding. So in metal carboning, you will get synergic bonding. should I take after